All right, hello, welcome back. We're going to talk about sections 7.2 and 7.3 today. I'm not sure really why the book splits this up into two sections, but 7.2 and 7.3 are about multiplying polynomials. There aren't nearly as many definitions in this section. In fact, there are no definitions in this section. We just have to use what we already know. But the section of this is we're going to multiply. So we added and we subtracted in 7.1, and now we're going to multiply polynomials. We are not going to divide polynomials. That's a whole nother beast to conquer. And we're not going to do that, but you will do that in Algebra 2. So for now, we're just going to be happy with multiplying. All right? And basically, I'm just going to do a bunch of examples here. There's not a lot of definitions to talk about. So let's just talk about example 1. Okay? And example 1 is, what if I gave you 3 times the quantity x plus 1? And most of you would say, well, you would distribute. Okay, so let's distribute. So 3 times x, and then 3 times 1. So 3 times x creates a 3x, and a 3 times a 1 creates a positive 3. And that is where you would stop. That is all that you do. You just distribute. Okay, multiplying polynomials is just going to be a bunch of distribution. So that's kind of exciting. Okay? So now let's look at, well, what if we have here with example 2, what if I had the same idea except I had x on the outside and then I had an x minus 2 on the inside? Okay, so here we've got a monomial multiplied by a binomial. Okay? And so we're going to do the same thing. We're going to distribute. We've got x times x. Well, you know, because we've talked about powers, that creates an x squared. And you've got an x times a negative 2, which then creates a negative 2x. And because you all have mastered sections 7.1, you will now understand that you can't combine those and that you're done. And that's all that you can do there. Okay? We just got to stop there. All right? So that's as basic as you can get with this. So now the meat here, the big idea, if you will, is now what if we have two binomials multiplied together? So like these are both, we have one monomial multiplied by a binomial, okay? But what if we now have a binomial of, say, 2x plus 3 times x plus 5? So now we've got two binomials multiplied together, okay? And the whole idea of math is that we take something that we already know and apply it to things that look the same, but not quite, but we could probably still apply the same ideas. And so here, when we're multiplying polynomials, remember I said earlier that it's just a big distribution problem, right? And that's what we have here. We have a big distribution problem, except for the fact that now we're going to take everything in this first binomial here and multiply it by everything in the second. Okay, so let's start with the 2x. Let's take the 2x and let's multiply it by the x, just like we did distribution earlier. And 2x times x, that creates a 2x squared, right? You got a 2 and then 2 x's. And then, but x isn't the only thing in that term. Now you have to take 2x and bring it to the 5. And 2x times 5, well, that's just 10x. Right? 2 times 5 is 10. There's only one x. That's fine. We can combine things like that. You can combine things of unlike terms through multiplication, but you cannot combine them through addition or subtraction. Okay? But, unfortunately, that's 2x isn't the only thing in that first term. You've also got the 3. So we've got to take the 3 to the x, and that creates a positive 3x. And you take the 3 to the 5, which then creates a 15. So you've multiplied everything by everything, except for you're not going to multiply the 2x times 3 and you're not going to multiply the x times the 5 because those are already added together. So you've already taken into account the relationship between those two with these addition signs here, okay? And the last thing we have to do here is combine like terms. So we've got a 2x squared, and then 10x plus 3x is a positive 13x. And then we've got the positive 15 out on the end, and that is all that you can do there. Okay? Just stop right there. Beautiful. I think we should do one more like that, and then we'll do a couple other interesting things. So Let's see what happens. Let's call this example 4. All right, and on example 4, let's take the quantity of n plus 2 and multiply it by n minus 2. So still, two binomials multiplied together. So let's just concentrate on this first term. We have the first times the first, which is n squared. And then I've got that one to the second one, which would be a negative 2n. Now let's worry about that second term in there. You've got a 2 times an n, which is a positive 2n. And then you've got to take this 2 to the end there. And 2 times negative 2, make sure you watch the signs. 2 times negative 2 would be a negative 4. And so now we have to combine like terms. N squared is the only n squared, so we keep that n squared. I've got a negative 2n plus 2n. Well, that makes 0n, and you could write 0n if you wish, or you could just not write anything and just keep that minus 4 on the end and call it a day. Boom. That's exciting. This is the most exciting thing you've ever learned in your life, isn't it? Awesome. All right, what if I gave you here with example 5, what if I gave you something like 2x minus 3 quantity squared? Okay, now this is a little bit different because here's what you're going to want to do because you've studied exponent rules. You're going to want to do this. You're going to say, okay, well that goes to there, so that's a 2x squared, and then that goes to there, so that's a minus 9. And I'm going to tell you that that is so very wrong on so many accounts. Okay, so you cannot distribute an exponent like that. Okay, you can't distribute an exponent like that. Remember, if you have something like x squared, that's the same thing as saying x times x, right? It's the same thing twice. So if you have 2x minus 3 squared, that's like 2x minus 3 times 2x minus 3. And now we have a problem like example 4 here. Okay, so now we can distribute. 2x times 2x, that creates a 4x squared, right? Because 2 times 2 is 4, and x times x is x squared. And then we've got 2x times a negative 3, that creates a negative 6x. And negative 3 times 2x also creates a negative 6x. And then a negative 3 times a negative 3 creates a positive 9. And now we can combine like terms. So we have 4x squared, negative 6x minus 6x is negative 12x. And then we still have that plus 9 over there on the end, just like that. So you see, these two things are not even remotely close to each other, not even a little bit. Okay, and I know that some of you are still going to do it. Please don't do that. Please, 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 please don't do that. Okay. Excellent. One more. Let's do one more here. Let's look at example 6. All right. Example 6. Let's take the quantity of f plus 1 and multiply it by f squared plus 4f plus 8. So now we have a binomial multiplied by a trinomial. Oh boy. Well, the good thing is all of the ideas stay the same. You're going to take every term here and multiply it by every term there. Okay, so let's start with this first one. We've got f times f squared. So you've got 3 f's. That creates an f cubed. Okay? You have f times 4f. And that creates a positive 4f squared. And then we've got an f times an 8, which creates a positive 8f. And now we deal with the 1. We do the same thing. 1 times f squared is a positive 1f squared. 1 times 4f is a positive 4f. And a 1 times an 8 gives us a positive 8. And now we can just combine like terms. All right? F cubed, that's the only f cubed that we have, so we keep that as f cubed. We've got a 4f squared plus 1f squared, so that creates a plus 5f squared. Then we've got an 8f plus 4f, that creates a positive 12f. And then we've got a positive 8 out here on the end. And that's where you stop. So really nothing different, just more. You guys confuse more with more difficult, and that's not necessarily the answer, okay? All right, rewind if you need to, have your questions ready, and we will expand upon these ideas tomorrow in class.